Okay, so in this lesson in Cinema 4D, we are going to talk about rendering inside the program. And this is to export, to send out the quality work you've done. I have this little spaceship here that I'm looking at that looks like this. This little spaceship comes into the scene and lands on these two little platforms right here. And I have little track solids or little planes from After Effects that have a little shadow catcher on them. Here's my little shadow catcher on the edge there. You can see here that the shadow catcher is in here. It has about 50%. So pretty cool, pretty cool. I want to show you that this references actually this video here in After Effects. So in After Effects, I have basically this reference here. We're looking this in current draft mode. We can switch to, say, viewport and just see this as kind of a low-end version here. And you can see it lands in these two little planes right here. It kind of moves into the scene there. But in current, you'll see that it actually has the shadow that's occurring here. If you look closely here and zoom in, you can see a little shadow that exists inside of there. So a little bit of that, you can see basically all that good stuff there. So we have this in here. Let's go back into Cinema 4D. Now we want to take this and send this out of Cinema 4D so that we can just use it instead of having to use the Cineware plugin to kind of work with us. So let's look at some of the settings. So we know first off, immediately we have this ability to render inside of here. So Command R renders in the viewport, and we can look at this inside here. But this is going to show, we have a physical sky here that's going to show the sky in the background. We have these track solids that exist. They're going to be there. They're going to be invisible and just capture the shadow, but we'll keep this as is. But we're going to basically use this in this kind of capacity here. We're going to make this track solid maybe a little bit bigger. Let's just go to T and just make it a little bit bigger so it covers over the whole ship there. And so it makes a decent shadow there. If we turn this off, for example, if we got rid of these, just to show you, we got rid of these, we hit Command R, you might see some shadow that exists underneath these. Again, we can change this shadow, or we could use another kind of light to make the shadow. But we'll leave these here. We're going to undo what we just did, put these back. So they're going to come back into here with the shadow. So that is Command R. That's the quick way to render inside the viewport. So that's just your viewport render. That's this button right here, like so. The next button next to this is to render to the picture viewer. So render to picture viewer, which is going to be Shift R, but we don't want to do that just yet. Let's just test this out as an idea. So we're going to go in here into the render settings. We're going to start talking about some things we want to do. So in here in the render settings, here's the basic render settings, and it asks us what kind of renderer we're using. And right now we're using the standard based renderer. This is kind of the default for Cinema 4D, or actually in the new version, you also have the ability to use the Redshift render. They've now switched this to the default. We'll talk about Redshift very briefly, but we won't get too deep into it. We'll talk about some of the render settings. But before I hop into here, let me take a step back, relax, calm down, slow down. And we're going to do some changes to this to really kind of work with this footage here. So for the physical sky, I don't want to see the physical sky. Now I know that when I work inside of After Effects in here, you'll see that the physical sky doesn't exist. You don't actually see the sky that's around here. It becomes transparent. And that's because it's using the C4D and using Cineware, which Cineware takes the liberty of saying, hey, let's just remove physical skies because we don't need to see them. But when I do export this out of here, outside of here, it's going to show me the physical sky, which is not something I want to see. So I'm going to go to the physical sky, and I'm going to right click, and I'm going to go to my favorite tag, my render tags compositing, and turn off in the tag the scene by camera. So now it's not there. It doesn't exist. It's still coloring this. So if you see, if I turn this off, you'll see the colors may change. It's still going to color this differently based on the sky and what the sky is going to do, basically how this is. So if I render this out, it's not there anymore. If I turn this off, you're going to see a different render altogether. Notice the color changed because I didn't have the physical sky on. When the physical sky is on, when you render, it's going to add that colorization to that. And we can obviously move this physical sky around. So again, if we turn off this scene by camera, you'll see I can move this sky, hit the rotate control for the physical sky, and rotate the sky in some direction to change what the overall look of the sky, basically how it looks inside of there. But we're also going to have it not seen by camera. So we're going to turn that off. And we can have that set up like there inside of that in Cinema 4D. If we wanted to put anything else in here, we could do some other things for how to render this. But for now, let's go back into the render settings. We'll talk about some ideas here. So the first off is under the output section. The output section says, hey, what are we outputting this at? Well, we're outputting this at 1920 by 1080 because our video that we want to put this over is going to be 1920 by 1080. That's full HD. You obviously have a control where you can choose different resolutions, different video resolutions, 4K, UHD, Cineon, film 4K, 4096, whatever it is, resolution pixels per inch. I'm not really concerned as much about that. I'm pretty much want to take care of the whole thing. There is a control for the render region. We can talk about what the render region is. And we can see what that is. Actually, I'll talk about that right now for a second. So there is a control in the render menu. So if you go to the render menu, there is something called the interactive render region. And the interactive render region looks like this. And it will render out this area here. And you can actually take this interactive render region, you can move it around and say, oh, I just want to render this. Sometimes you have a complex scene and you don't want to render everything. You just want to have something that's live all the time. And this is called the interactive render region. You can make this bigger or smaller. And there's actually a little slider here where you can increase the quality. This is just a temp render for this. It takes a little bit of RAM to do. We could render it at super low quality and have it just do a really cheap render, but it just shows us what it looks like, what it's going to look like when it renders. That's really garbage quality. Let's bring that up to here. It's going to render it again. This is called the interactive render region. It's this little interactive render region button right here. So that's in the render settings here. Sorry, render inside of here, the interactive render region. Well, what it says here in the settings is, hey, do you want to just render the interactive render region? You can set up your own render region, set your own left borders there, or you could copy from the interactive render region and just copy that there. But we don't want to do that. Let's avoid the interactive render region. I just want to show you that it's there as an idea. So what are we doing? We're doing HD TV 16:9. We're using square pixels. We're doing 24 frames a second. And now it offers the option, do we want to render all the frames or do we want to render just the current frame? Well, let's just for now, we're parked on frame 98 here. Let's just render the current frame. We're not using interlaced video, so we don't have any fields. We're just going to do this in straight progressive video. That's fine. Let's talk about saving this. So what format do we want to save it to? Well, typically we want to save this to a series of still pictures. We can save it as an MOV or an MP4, but I would recommend not doing that. That's probably not your friend. Why? Because you render an MOV and you get halfway through and your system crashes. Heck, my system crashed already once this morning. I'm just unlucky. It's a bad rainy day. I'm dealing with it. So let's not do that because sometimes this takes a long time to render. So you see we can render as a series of pictures. Some people would like to render as, say, a PNG. Portable network graphics. Some people render as a JPEG. JPEGs are okay, but they don't really support alpha. And then we can render here as some other format. We'll talk about TIFF and we'll talk about OpenEXR as well as rendering as a, I don't know, a PSD, a Photoshop document. Some people like that as well. I'm going to render as a TIFF. I like the TIFF format. It's high quality. It's there. And we're going to say the render depth is going to be 8 bits per channel, or should we do 16? Let's go crazy. Let's do 16 bits per channel. Let's trust that we put a lot of color and brightness and luminance information into this, and we want to render the full 16 bits, the millions of colors that we could possibly have. We're going to render 16 bits per channel, which, I don't know, somebody do the math. That's like 48 bits total out of the red, green, and blue. And we're going to save this here. Now, we could choose not to save this, which would save this later. But we're going to choose to save this. We're going to go in here and select a file to save. And we're going to go in here and say, let's just make a folder on the desktop. And we'll call this renders. Renders. Maybe we'll make it kind of cool and punk rock and call it renders with a Z. Yeah, that's totally cool. Anyway, we'll make a folder here called renders. And we're going to call this TIFFs. TIFF ship. Yeah, that sounds good. TIFF ship. Okay, cool. So this would be the TIFF ship of the TIFFs, which will be saving as a TIFF file. Now, it asks us a bunch of questions. Do we want to export an alpha channel? And the alpha channel, remember, is the transparency. Now, if we render this out and we render this out just like this, like in here, when we say Command R, it's going to put it over black. It's going to make it black in the background. And we could try to eliminate the black, but we don't want to do that. We want to actually render this with the alpha channel. That way, it's easier for us to do it. So let's turn on the alpha channel. We could do it with a separate alpha. So that would be rendering a separate channel that we'd have to use in some kind of compositing program like After Effects or something else, even Premiere or Avid or something that we could create some kind of a track mat basically there. We're going to leave that alone. We're going to embed the alpha because the TIFF will actually embed the alpha inside. Notice, for example, the JPEG, I think, forces it to do separate alpha because it'll separate as a separate file because it doesn't support that. So basically, you can work that way, but we're going to export the alpha channel inside here, 16 bits, and that's all. But that's well and good. There's also an idea that I rarely play with, but we can talk about, which is the compositing. You can actually save a compositing project file, so you can actually create to save a After Effects file or a Nuke file or a Final Cut 7 or a Motion file. So this will actually create, in this case, an AEP, an After Effects project that would actually save its own project, basically including timeline markers and 3D data and all this other information. It's kind of really cool, but honestly, we already have our After Effects project here, so I don't think we need to do that. I think we're just going to leave that alone and not save a project file at all. Okay, let's talk about multipass in a second. We'll leave that alone here, but we're going to talk here about, we don't want to do stereoscopic. We're not making the next Avatar movie. I think we're okay. Let's look at options in here. So in options, I don't really mess with options that much, but there are some things we could do and some controls we could have. We could talk about some controls in terms of, do we want to export the transparency? Yes, we want the transparency information to be included. Maybe we just didn't want this to be transparent in certain places. Maybe we didn't want certain refraction or certain reflections, or maybe we just didn't want the shadows. We said, hey, just do this without the shadows. Why would we do that? I don't think we would. I think we'd export it with all this information inside of here. And you can say, hey, export it without the textures. And yeah, we could, that would be silly. That'd be kind of foolish. Anyway, there's things you could do if you wanted to turn off. If you wanted to include the display tags in there, you could turn that back on and have it there. If you want to show, so this is normally what this is. You could just export the active objects alone. So if you just said, hey, I only want to export the whole ship's right engine, you could export active objects only. That's kind of crazy. So you could export just that part. Interesting. So there's a lot of freedom, a lot of things you can do, a lot of controls you have. So we're going to leave this alone here for a second, and we're going to say, okay, this is fine. But before we do this, before we export this, I want to show you the worst way to render this, or the most economical way to render this. And this is called Viewport Renderer. And Viewport Renderer really loses all the options here. It gives you a save, where it's going to save to. We're going to change this. We're going to change this from TIFF ship here, and we're going to say this we're going to call this view ship for the viewport ship. And we're going to save this here as the viewport ship. Now, the viewport renderer says, hey, do you want to save all these things? We don't want to save shadows or reflections or this or tessellation or all these things. We're going to keep this there. We don't want to add magic bolt looks in here, but we're going to save this just as the viewport view, which means it's going to save it looking like this. Why the heck would we do this? Well, we do this because it's really fast, actually. It's really fast. So we're going to here, just as an example, we're going to just save a viewport view, and we're going to hit Shift-R or render to viewport and say Shift-R, boom. And so that's going to open up something called the picture viewer. And so here it's going to render this out, and you're going to see that it's going to take the time. It's preparing right now. Just let it prepare. Relax. It's okay. And now it's going to render out this one frame. But let's actually render out all the frames here. We're actually going to delete this, say goodbye. Cool. And we're going to do this, all the frames here. So we're going to say in here, viewport render, the output is going to be all the frames, all the frames. Because I want to do this here as all the frames, just to show you what I could do with this. So again, we're saving to viewport render. We're going to hit Shift-R, boom. And it's going to render out this first frame. And then it's going to do all the frames. And it can do all the frames really quickly. Look how quick that is. It tells you actually how long it takes. 3 seconds, 0 seconds, 0 seconds. I mean, it's going to be done. It's going along here. It's going to be done in no time at all. And here's the reason why we do that. So let's take a look. We're going to hop back into After Effects just for an example. And we'll go here in After Effects and we'll say, let's turn off the sky reference because we don't really need that anymore. And we're going to turn off the track solids because they're off. We don't really need them anymore. And let's bring in this video. So we're going to bring in this video inside of here. And we're going to go to desktop and we're going to go to render Z. And this is the view ship. So this is the view ship inside of here. And this is all these frames. What we can do, look at how fast they're going. We're already up to 85. That thing's just humming. So we're going to start here and we're going to say, let's render this. Let's create a TIFF sequence out of this. And so the TIFF sequence says, hey, let's render all this out. And we're going to create one sequence out of this. We're going to say open and render this. It's going to ask us, are we using straight alpha? Yeah, sure. And we're going to render this here. And now we have all these frames here. Now, the weird thing that happens is we have all this, we have 5 seconds already of this animation. My concern is that when it brings it inside of After Effects, it brings it in at 30 frames per second, which is not what I want. So let's do it this way. Let's go in here. Let's right click, interpret footage, main. And let's say, no, dummy. This is 24 frames a second. I wish there was a way that we could permanently tell this. I always work in 24. Please stop changing this to 30. Now it's actually 6 seconds. And we're going to add this into the sky and see how this looks. Now, this is going to look kind of mediocre. You can see the frame. You can see the whole thing. But this is how it comes into the scene. You can see this here. We're going to turn the audio off here for a second. It's going to come in here and land, and then boom. Does it look like garbage? Can you see the outline and everything else of all the things? Yeah, but at least it tells you what the heck you're doing and whether your timing works. This is a great thing for, just getting a reference of seeing what my timing looks like. Well, I've only rendered out 6 seconds. So let's go in here. Let's right click and reload footage. And now it's going to give me, oh man, look at that. It already rendered 18 seconds here. It's practically almost done. And now I can just watch this in here and see how this renders and see, okay, this is how I want it to land. This is not how I want it to look, but this is how I want it to land. And this is pretty good inside of here. Okay, so that was my first render. I bet I'm almost done by now. Let's see how long I am. Reload. I keep doing reload footage, and now reload footage. Man, I just finished. So now here, if I look inside of my desktop, inside of renders, I have all this view ship here. So anyway, we have all that, and so we rendered that out. So that's a nice way to just preview what you're doing to get a chance to see that. We're going to delete that. We're going to delete it from here just because I don't think we need it anymore. Now we're actually going to render this out a little bit better, and we're going to do it here. So let's go back to Cinema 4D. And I'm actually going to go and I'm going to delete these. Maybe I'll put them in a folder. Just for now, I'll put them in a folder. We'll go to desktop. Or we'll just call this, we'll call this render. We'll call this render viewport. So that was going to keep this all in there. So in render viewport, you'll see I have all these frames in here like so. And they're all like this. And it actually included the alpha channel, which is nice, but it made this kind of there, coming in there. Looks like something wrong with my ship, but I'm going to pretend like everything's fine. I might have to fix it a little bit, but we're going to be okay. We're going to be okay. We're just talking about rendering. We're not talking about all the problems with my ship, of which there are many, but we're going to talk about it in here and talk about there. So we're going to keep this cool. So it made this basically this huge list of all 480 frames. Like so. So now let's go into standard renderer. So in standard renderer, we're going to go here and just to say viewport standard, and we're going to choose the standard renderer. Again, we'll double check the options, the save options, the other options, and all the other things. There is an option here for team render. Maybe if we get a chance in a little later, we'll talk about team rendering. This is to use multiple systems inside your team render options, and we can talk about that as an idea. So if you are in a lab that has multiple computer systems, I can turn a whole bunch of computer systems on and talk about team rendering inside of here. But we're going to render in standard, and this is going to be the standard render. So this is going to look like, basically when I hit Command R, it looks like this. This is what it's going to look like. Let's just save this as a separate folder. So we're going to go in here into output or save. We'll choose a different folder. We're going to go to another folder on the desktop. We're going to call this standard ship. And I'll call this stand ship, because I stand it so hard. I don't know. Is that outdated? Am I an old person for using lingo that's already probably passe? Probably. But anyway, so we're going to save this as a TIFF file, and we're going to export this as a standard. Now we're going to do output. Instead of doing all frames, I'm just going to do from frame. I want to get really the action to this. So I want to go from here, basically where the ship comes in. We're going to go from frame 64 to 96. So we're just going to say, I'm going to choose frame 64. Whoops, not 640. 64 to 96. So I'm going to render those frames out in here and do a partial render of that section in there and say, awesome, let's do that. So now we're going to hit this again, or we're going to hit Shift R, and it's going to render out these frames. Now this is going to take longer. Why? Because it's not just doing a viewport pass, it's doing a render that's rendering this. And you can see that now this one took 3 seconds. This one took 3 seconds. This one took another, 3 seconds. So we're rendering this out a little bit longer, but this is obviously much better quality. Now I want to show you really quickly, if you go in here, you can actually zoom in and zoom out, show smaller areas of the screen, and kind of zoom in and show different parts of this and see how this is doing and see the work that it's doing. We can zoom in and zoom out. But there's also a section that says history, which is showing you what it's doing. Here's the view ship. Here's the stand ship. We have both those ships there. We have the info, which shows you basically what it's talking about, what it's doing, and give you some information about when it's doing it. And then the layer. The layer is interesting because it will actually show you whether or not it's importing the alpha channel. Right now, we're looking at the image. The single pass, we can look at the alpha channel. And so we can look at just the alpha channel and see what the alpha channel will look like. So notice you're seeing this little bit of gray there for the shadows. You're seeing a little bit of this here. So you're seeing a little bit of quality there coming through. The rest of this is black, but this part is shadow. So we see that somewhat. So it's semi-transparent, but that's an interesting way to look at that in there. Let's go back to image. Let's go back to history. We've already done 64 to 82. So now we can go back in After Effects and say, hey, let's bring in this as well, let's go to standard chip and let's bring in this standard chip, 64 to 82. And we're going to say create TIFF sequence. You can also choose force alphabetical. Force alphabetical is if there's a problem, like there's a missing frame and you're like, hey, just ignore the missing frame and just go from there. Or something was wrong with one of the frames or just miscounting and you just wanted to count right. It just says, hey, ignore if the numbers are off and the numbers aren't perfectly sequential, force them to be alphabetical and have them there. We're going to say create TIFF sequence. And I'm going to say straight alpha, sure. And let's bring that in here, and we're going to throw that on top of this and see what this is. Now, this is obviously at frame 64 to 91 is what we have right now. So we can actually render this again and say reload footage, and I think that's everything. I think that's 64 to 90. I forget we did 64 to 90 something. 96 maybe? Yeah, a little bit more. A couple more frames, reload. Yeah, I think that was the full range we did. So here's the problem is that this doesn't actually form in exactly where this is. So I'll show you a trick. If you're in After Effects and you hold down Command, click the time code, you can see the time code in numbers, and we can park this right on 64 and then hit the bracket key next to the P and move that to there. So that's how this would land. It would land right here. And that looks a little bit better. You're seeing the shadow that's coming in here. It's landing a bit smoother there, and it's landing on that platform. Bam, right there. And so we're seeing that come through inside of here and landing perfectly fine. So that's cool. Excellent. So let's look. So we have this rendered out. This is still rendering. Oh, this is rendering out more frames. Interesting. Still going. Look at that. Did I forget to put 96 in there? All right, we're going to stop this. I'm always worried about stopping a render, but we're going to stop it anyway. We're going to stop rendering because I think you got the idea. This external render is calculating an image. Do you really want to stop? Do you want to stop it? Are you sure, you dummy? Yeah, let's do it. Let's stop it. So now we're going to stop this. We'll leave that alone. We have that there. Anyway, so we're here in the render settings, and we can see that we have this basically rendered out this way. So let me see what was going on with the output. The output was rendering 64 to 480. I never hit 96. Yeah, that was my problem. Cool. I was going to try and render to 92 or 96, but no one caught me. You guys didn't say anything. You guys didn't even say anything. You notice I totally missed hitting 96, and it was just going to render out all those frames. What a waste of time. Anyway, that's fine. I do want to talk, if we're going to talk about rendering, I do want to talk about two more things that I do want to add. And those will be the ideas of including both ambient occlusions and global illumination. For my money, I always include ambient occlusion and I always include global illumination in my renders. And I'll tell you about both of what they mean. Let's go to a separate window. Okay, so in here, what I'm going to do is I'm going to take a cube and I'm just make a cube. And I'll add a little bit of filleting on the edge of the cube, maybe a little bit of roundness here on the cube, maybe change some subdivisions and see some subdivisions there. And actually, we're going to make this cube on a plane. We're going to put this on a plane, and we're actually going to take the cube and raise this up and put the cube up here, just so it's on the plane, just resting right there, kind of just on the plane. And we'll make the plane a little bit bigger. Hit the T key, make this bigger. Cool. And A, just so we have it there. I'm going to put some materials on this just to show you some materials. We'll just create a default material here, just cubes there, and good enough for me. We'll make another material for the plane. Cool. Just we'll have those there. We'll maybe make the cube, the material for the cube. No, that was the plane. The cube for material and make this kind of a shade of green, maybe a shade of green. Cool. Excellent. So one of the things that we have here is that when we render this, we have this Command R. You'll see that it's just perfectly on there, and it looks amazing. Now, we have no shadow, we have no light, we have no thing, but there should be a little bit of shadow. There should be something, what's called an ambient occlusion, and that's just because this is in a lit environment, and because this is blocking some neat under there. So if you look around your desk and you look at everything on your desk, there's always a little bit of shadow, and that is called an ambient occlusion. So we're going to hear render settings, go to Effect, and go and choose Ambient Occlusion and turn that on. Now, there's some settings you could do about the intensity of this, and there's some controls you can do in here about there based on what the Ambient Occlusion does. And now we can hit Command R, but now you can see there's this little bit of shadow underneath there. There's a little bit of something there that has this Ambient Occlusion. And again, like I said, you can go in here and throw an ambient occlusion. I love ambient occlusion because for things like if you have this shadow, and say, for example, you make the shadow editable, and you were to say here, hit the C key and say, let's make this editable. And you were going to do something fun, like you were going to inset this and then extrude it back and then inset it again. I'm hitting I and D and extrude it forward and then inset it again and then say D and then pull this out like this. Then I'm just making some shapes here, there. You'll notice that in here, if I were to go with this and I were to say, let's not use ambient occlusion, turn that off. And I were to render this, it would look like this. I mean, that's okay. You can see a little bit of shading in here. It looks average, but not great. But here, if you add the ambient occlusion in, all of a sudden you get this whole kind of really cool, it looks really carved out. It looks really nice and more realistic there. And you can increase the accuracy of there and really have it render really nicely, and then really have some controls. Change the maximum number of samples it can do. So you can change it up to 256 and then increase the quality there. So there's really some settings you could do to make it really look pretty instead of there. And there's some nice controls that you have inside of there. So that is one called ambient occlusion. And now the second one I want to talk about while we're here is we're going to talk about the idea of something called global illumination. And that is the setting here under effects called global illumination. Now, global illumination will do two things for us. The first thing it will do is it will actually allow for bouncing. So allow for a light to bounce through something. So let me show you an example of this. If I were to take a cylinder, let's try to turn the cube off for a second. We're going to hide the cube for a second. And I already take a cylinder. I'm sorry, not a cylinder. Let's forget a cylinder. Let's take a tube. This might be easier with a tube. If we want to take a tube here and I turn my tube, let's rotate my tube, or let's just go here in the axis controls. And we're going to put this on the Z axis here. We'll change the number of rotation segments to like 48. So it's rounder. We're going to take this and move this up. And we're going to make this super long and stretchy. Maybe make it thin, or maybe we'll make it like this. We'll make it bigger inside here. And we'll go in here and look in here. Now, if I were to take this and I were to say, let's move around here. And let's say in the center of this, I put a cube. Let's say I take up a cube and I'll just put a cube in the way, just like this. Now in here, one of the things that will happen is that this cube is here. If I were to put a light in here, now I'm going to take a light. I'm just going to position a light in the back of this. We haven't really talked about lights, but we're just you understand that a light exists. We're going to take a spotlight. We'll take this spotlight and we're going to put a spotlight right here. Up here, we're going to rotate this maybe 180 and put this light right in the middle of here. We're just going to look, and this light is kind of shining through right inside of here. We'll make this a little bit bigger. Whoops. Go to the edge of this. Make this light shine here. If you were to look through this light here, if we were to look at the other side of this, and we were to render this, and we'll put a material on here. We'll just build a material. We'll put a material on this tube here. And so now this has a white material here. We'll make this super white. Inside of here, if we were to render this, it ends up looking really dark in the front. It doesn't look, oh, sorry. Let me turn global illumination off. There we go. That's better. So in here, it looks super dark, or it doesn't shine the right way. It doesn't shine on the front of this. And so the front of this doesn't get any proper lighting. And that's silly because this, for example, the cube would have, well, the cube has, we'll take this cube here, has material on it, and this is material on it, and now we have this light shining through. So in here, what we have is when we turn global illumination on, light is going to bounce off of things, and light is going to bounce off of these objects. So we're going to hit Command R, and we do that, you're going to see that all of a sudden the front of this gets lit up. Why does this get lit up? Because the light bounces off the inside of the tube. So if you ever had like some place where there was something going on, for example, just for example, let's get rid of this. We'll get rid of this cube and the tube. Actually, we'll get rid of this cube and this tube, and we get rid of this. And we were to say, let's take this inside of here. And we were to say, let's just take a different cube. Take a different cube. I'm going to turn the light off for a second. Get rid of the light. We're going to take this cube. We'll bring this up here. Make this wide like this and big in here like this. Cool. Big cube there. Excellent. We still have our light. We're going to take the light here and we're going to go inside of here. We're going to make this editable. Hit the C key, make this editable. We'll grab this side of this thing. We'll go inset I key. We'll drag in smaller. And I'm just going to hit the T key and just drag this like this and make a little window here. Maybe we'll even move this window over just so it's like that. Cool. And I'm going to go here and I'm just going to say, let's grab this and let's say delete. Oops, sorry. And let's go here and let's just say delete. And we're going to make a hole here. So now we're going to take our light and we're going to put our light inside the hole here. And so we'll take our light and grab our light and move our light up to the hole, and it's going to shine into the window right inside of there. So here, we're going to turn the light off for a second. If we were to look through here, and let's just say we make another hole here, just as an idea, we're going to grab an edge here, hit the inset key, we're going to make this smaller. Again, the T key, we're going to make this super small like this. Hit the E key and move this over and make another hole right there. I'm going to click on this, hit delete, and make another hole in there. So inside of this hole, inside of this hole right here, with this light, we should have a light that shines through like there. And we can look inside and see that the light is only shining there. Again, without global illumination, we'll put a material on here. Without global illumination, we get kind of this. We get darkness except where the light shines. But the light is going to shine and going to bounce. So Command R, boom. We get this kind of mediocre, not really a good, decent light here inside of the screen like so. But here, if I go through and I add in global illumination, well, guess what? The light is going to bounce. So the ability to have the light bounce, now you see a different room because, you know, it's more real. It's more real. So I always say, as an idea for doing other images and doing other things, having the ability to have having in here effects, ambient occlusion, and we can crank up our ambient occlusion accuracy. We could change our number of maximum number of samples, 256, for example, or 250. Yeah, 256 is fine. There's going to go multiples there. And we could also add in effect, global illumination. And you can spend a long time talking about global illumination, about the different types of global illuminations and how it works. We're going to set the primary method to a radiance cache and the secondary method to maybe quasi Monte Carlo. And we can change the diffuse depth to maybe 4 and take a number of samples to high number of samples. This is going to take longer. We're going to spend a long time rendering out this one damn frame in this thing. And this is just in standard. There's a whole bunch of other controls. So really quickly, there are different methods of how to make the light bounce. It basically affects how the light bounces and how the light works. This is also, I didn't mention this before, but this is also how you would do objects that have some kind of luminance. So if you are using an HDRI for a sky, or you are doing some kind of a luminant object, if we wanted to say, hey, make this, we'll do an example here. We'll go to the ship here. We'll grab this piece right here, and we'll grab this. Let's grab that guy right there. And here we have this cube, this bent cube right here. This is this guy right here. And so basically that guy. We're going to take this guy, and for this material on this guy, we're going to say, or maybe both these materials, we're going to go to these materials here, and in these materials, we want this material to have luminance values. And so now this is going to be glowing red. Well, guess what? When you don't do global illumination, it doesn't really glow red. In order for something to emit light, Command R, it's going to look bright, but it doesn't emit light. It doesn't have that light emitting quality to it. So if we want that light emitting quality, we want to turn on global illumination. But again, global illumination with this primary method and the secondary method, this all affects how the light bounces. There's a couple of presets you have in there, but you can play with it a little bit there. But now this can take a little bit longer to render. When we hit Command R, you're going to see it's going to first start doing the global illumination pass. Here's the viewport rendering, irradiance, cache, pre-pass, main pass, 1 of 1, 4 of 4. And now you're going to wait, and it's going to start to render inside of here. And now we'll start to have some illuminance inside of there. So the ability for an object to send off light. If, for example, we didn't have the physical sky, we said, forget the physical sky. We'll go in here and say no physical sky. You will see that just this, without the physical sky, is not going to create any kind of light environment. We're going to say Control R, and you're going to see the only places where it has brightness whatsoever is where this global illumination is. It's rendering, it's rendering, it's rendering. This is taking longer. Remember not to touch anything. Viewport rendering, irradiance, cache, pre-pass. It's doing the passes. Oh, man. It's taking a little bit longer here. Should we wait? But you can already see right here where this is the only thing that's providing light here. And now this is glowing. So this is our light source. This is our only light source. Takes a longer time to render. You see these little buckets, they're called, lighting up more. They become a light source. Without global illumination, hard thing to say fast, Command R, this will render like this, and it just looks normal. It just says, hey, this is not actually a light source. If you want something to illuminate to become a light source, we're going to have it like there. I'm going to do these track solids and say these track solids are under the render tags, and they are going to be a compositing tag, and we're going to say not seen by camera. So hopefully that will do that. We're going to duplicate that, command drag that on top of there, and have that not be seen by camera. I'm curious if that's going to do what I want to do. Yeah, so now I don't have to cut in the middle of there, but I will still see the shadow. Cool. So we're going to turn on, again, we're going to turn on global illumination and ambient occlusion and see what happens. We'll turn the physical sky back on because I really did like it. Anyway, so now we're going to go in here and we're going to look at a render setting. So we're going to be here with global illumination and ambient occlusion. I'm just going to save one of these because I don't want to take the time. Maybe we'll save like 10 of these. We'll go 64 to 74. We'll save this as a new file, a new render. I know, desktop. We'll go here to Stanley ship. That's going to be my new Stanley ship. And we're going to this as a Stanley ship. That means that's standard with Global Nation and Ambient Occlusion. That's like an industry standard. Anyway, I'm just making this up. Don't ignore me. So Shift R, here we go. Let's render this. Let's see what it does. Now it's doing this. The ship here. And again, this is taking some time. It's going to go through here and going to go through each frame. Isn't it nice that we had that viewport render? Because that viewport render gave us a chance to kind of preview what the heck we were doing. And we could put it inside of some of the program like After Effects or Final Cut Pro or whatever. And we could see what it was doing to make, hey, it looks low res. It looks like crap. But at least we know the animation works. It's a nice way to review kind of an offline edit of what you're doing. Anyway, let's see how long this takes. We're up to 30 seconds already. I think one frame is going to be 40 some odd seconds. A lot of detail. Up, 39, 40. All right, good. 40 seconds exactly. Look at that. So now it did that one frame. Let's just look at that one frame inside of here. Let's go to desktop, Stanley ship, and that one frame. Okay, so now we're seeing in the cut and the edges of this, we're seeing a little bit of that. We're seeing that global illumination. We're seeing the ambient occlusion. We're seeing the bright hot spots there. We could go in here and increase the global illumination, but again, we almost have 2 frames here. We can go in here and go to layer and see what's going on with the alpha. We're starting to see the cutout of the alpha of each image here. We go to the previous image here. We can go into the layer and see the controls of the alpha. Single pass alpha. So this is how it looks like it was cut out. So you're seeing those controls in there. That's something you can do, but that's going to take longer. I feel like we want a team render right now. I know it's a little too soon, but I kind of want a team render. But we're going to leave it alone. We're going to live with it for what it is there. Now, if we close this picture viewer, it's going to ask us, do we want to stop rendering? Do we want to just close the picture viewer? You sure do you want to stop the render? No, we won't stop the render. We'll keep talking. But here, if we ever wanted to, we go to Windows and go to Picture Viewer. Picture Viewer. That is Shift F6. Good thing to know. And now you can see the picture viewer and see what's going on with the render. And scroll down to all the previous renders. And now we're up to 2 frames. The second frame took 44 seconds. The third frame took 41 seconds. Man, this is really going here. Ooh, all of 3 frames here. It's going to take longer and longer the more stuff we do, the more complicated we get. It's going to be more involved there. I'm going to stop the render this time because I don't think we want to render all these frames. I think you get the idea. We're seeing some there. Really quickly, if we wanted to, inside of here in the, not the render settings, but in the material settings, in this material, there is some controls for illumination. You could crank up how much this generates global illumination. So if you have GI, that's what the cool kids call global illumination. You can actually strengthen up the amount of global illumination. We could say up to 500%. And then saturation up to 250%. I don't know. That's going to make it more redder. One is going to make it more brighter. And we could do that there. So let's crank this up to like 1,000. And so this is going to generate GI. It's also control whether it receives GI, but that's in here. We're going to go again, turn up the physical sky. We'll render out 1 frame. Just render out 1 frame. I know, we're going to be really gentle. Just render out the current frame inside of here. Frame 91. Feels like a good frame. And now we're going to say, Command R would be fine. Command R is going to render that 1 frame, and notice how much brighter. Sorry, let me hit Command R. And notice how much brighter it is already because we cranked up that global illumination. So if we really want to take advantage of all that illumination, crank it up. Oh man, you can see how much is cooking now. Again, it's doing this. You can always watch down here, see what's happening. See how this is really working. This is how we render out. Now it's creating the frames. And now you're going to see the ship is going to be completely glowing red by these red things that are glowing. Yeah, something like that. So you have those controls inside of there. You're starting to see a little bit more of the ship. Now it's very dark, but these things, that looks really cool. Anyway, so we're going to play with that. Anyway, we're going to go into some more advanced rendering. So now that we've gone to here, we can go in here and we're going to go to the physical-based rendering. So the physical-based rendering works this way. It works with a different control called the physical-based rendering. Let me explain what that means. Inside of here, we have the ability to control different types of engines that it uses to render. What does that mean? Well, it's using different types of math. There are different renderers out there. There are different controls that there. Built inside of Cinema 4D is two renders all automatically. Their standard renderer, which is kind of okay. And then they have something a little bit more advanced called their physical renderer. Now, we're not going to go into all the physical renderer settings. I should probably learn about the physical renderer a little bit better, but there are some controls that we do care about. So inside the physical, we say, hey, how do we want to render this? So let's do this way. Let's render out this frame here. We're going to turn the physical sky back on, and we're going to see this render out. We're going to lower the render settings here. In here, we're going to lower the illumination. We're going to bring this back to 100, 100, and 100. So this is going to have a little bit of illumination, and we're just going to render out this one frame in here under save or output. We're going to render out the current frame, frame 91, and I'm going to save this to the desktop. Inside of here, we're going to save, and we're going to save this to not Stanley Ship. We're just going to save this on the desktop. On the desktop, we're going to call this render standard. Cool. And we're going to render out this one singular frame like this. This may take, 40 seconds? Shift R, and we're going to render this here. So it's going to do all the passes. Again, it's going to take some time, but we'll see this when it's done. Again, it's going to take some time to do all what it's doing. Here it goes. I believe in it. Anyway, you want to talk about our feelings or something while we wait for stuff to render? Man, it's a good time waiting for stuff to render. So sad. And this is why, we render a series of single frames. If this render halfway through this, if this render took hours, which I've done renders that have taken hours, if this render takes hours and it crashes halfway between, guess what? That's all you got. You lost everything. If you're using like a QuickTime movie, you lost everything. You can't render half of a QuickTime movie. You either render it or you don't render it. But if you render a series of frames and you crash halfway between, you just pick up where you left off. So if you crashed at 1 through 63, you just render off, 64 to whatever, you render the rest here. So let's take a look at this. We'll go back to the desktop here, my messy desktop here. And we'll just say render standard. It looks like this. And so this is our ship inside of here. This is how it looks. Let's go here. Now we're going to get a little crazier. We're going to go here, and we're going to go into render physical. We're going to choose physical. We have global nation. We have ambient occlusion. We're going to turn physical on. Now it asks us some questions. Do we want to include some depth of field? Ooh, do we want to have some things be in focus, be out of focus based on where our depth is? Maybe we want to enable depth of field. Do we want to enable motion blur? Do we want to have that idea that as things move fast past the screen, they look somewhat blurry? We can include those controls of depth of field and motion blur. Those will be in your camera settings. So if you have a camera, you can go in here into the physical controls and you can talk about the f-stop will really control whether or not the depth of field is there. So we could lower the f-stop to say 1.1. This won't actually act as a iris, so it won't actually make the image brighter or darker. But it will mostly focus on controlling basically 1.1 is super low. Man. Yeah, let's leave it at 1.1. 1.1 is super low, but that would control basically how it's going to respond to a shallow depth of field, which means some things in the frame will be in focus, some things will be out of focus. We go to the object controls and look at our focus object or focus distance and say, hey, maybe we'll try this. We'll go to the whole ship. We're going to go here to the, I'm going to look for the, where's the engines? This engine's the left engine. I'm going to go back to the camera. And I say, for the focus object, I want the left engine. You got to drag it really quickly and put the left engine there. So now it's going to be focused at 919 inches away. And that's going to be the area of focus. So only this is in focus here. And so this is the part that's in focus. Hopefully we have a shallow focus. We'll take a look at how this looks. But that's going to be in the render settings. Now we're going to be even worse here. So we're going to enable depth of field, which means we're going to have render settings. In the sampling quality, there's a bunch of things. We can talk about the sampling subdivisions, the shading error threshold. This means, like, hey, it's going to try and shade this the best it can, but if the math is not sure, it's just going to kind of average it out and deal with it. 20% error, it's like an 80% student. That's a B- student right there. Some of my students know it's a B- student there. We can go here and we can say render at medium, which is a 5% error threshold, or at high, which is a 1% error threshold. That means that is an A+ student there that's doing all the work here. Now, the render method right now is under adaptive. We have adaptive, we have fixed, and we have progressive. Adaptive means that if there's something like the black background, it doesn't have to spend as much time rendering that because it's just a black background. This is one solid thing, and it doesn't have to worry about this as much. But some things, these sharp details in here, it's going to care more about. But we're going to do it at adaptive here. Fix would say, hey, just render at a certain quality, number of subdivisions, great, that's going to render more detail there. But we're going to do it adaptive, which means it's going to go between shading subdivisions between minimum 4, maximum 7. So if it's really complicated, it's going to worry more about there. It is an error threshold. Blurriness subdivisions, we could crank this up a little bit more. So we could crank up the blurriness subdivisions max and the shadow subdivisions max. We can increase these if we want to get that, but everything we do to increase is going to slow down my render time and make it a little bit more difficult to do. So let's take a look. Let's just try this at this level. We're going to hit Shift R. We'll close this out. We'll hit Shift R, deep breath. We're going to talk about a lot of things. Now, it actually said, hold on, let's cancel. Let's say, do we really want to overwrite this file? Cancel. Let's cancel, because what I did was I didn't save this the right way. Thankfully, it saved my butt. Look at that. I made a mistake. It saved me. Let's call this render standard. Let's call this one render physical. That way, it's going to do the same frame, but now we can look at the physical version versus the standard version and see if it's worth it. See if we get a better render out of physical. We may get a better render. We may not. Let's see. Shift R. I'm going to render physical, and now it's going to go through rendering the physical options. It's going to take some more time really going to find detail about this. It's going to go through these passes, and you're going to see the buckets might look a little bit smaller. It's going to be a higher detail inside of here. So while this is rendering, because it's going to take some time, we'll let this go here. We're going to minimize this here. I want to talk really quickly about the idea of team rendering. And this is the idea that if you have multiple systems, you can render across all those systems. And that first starts in here in the file controls. In the edit controls preferences. Command E, edit preferences, will bring up the preferences. And when it brings the preferences, there is a preference over here that says renderer. And in the renderer settings, there is the option for Redshift, and there is the option for team render. And team render says, hey, enable, you have to turn this on. This is not on by default. It asks for the team render, and it has those things there. So what you can do is you can share this across multiple computer systems. So you can share the rendering. So each computer system would take a frame, basically, or take a row of frames. So maybe this computer will take the 10 frames, the next computer will take the next 10 frames, etc. And it's a really interesting thing to set up. But if you have the ability to, and you have a lab full of computer systems, normally when you get Cinema 4D, you get a number of render machines, you get a number of render systems. And so what you can do here is you can say, hey, inside of here, you can go into the render controls and bring up the team render systems, team render machines, and bring the team render machines, and we'll show you the machines that are connected. Now, right now, I have a bunch of other systems here in my room. They're not connected right now, but if I double click, I can look for these and try to connect to them. But they're not, the computers aren't on right now, so I can't really connect to them. They do not have the render client open. But simply enough, when you have Cinema 4D, what you can do is you can go to Applications, and in Applications, somewhere in your computer, you will see that you have a team render client, and you can connect that team render client. Now, this is the computer system that's on the system, so it doesn't really help me. But if I go to another system, I can render out to that computer as well. You got to open up the team render client, which will open up another piece of software. But normally, if you get a version of Cinema 4D, you get 5 copies of the team render client, and you can render to 5 different computers. All the computers have to be on the same exact version of Cinema 4D. They all have to match accurately. They all have to be 100% exactly the same. And you can have this team render system there. And you can connect to different other render systems inside of the equation. Obviously, none of my other render computers are on right now, but you can click on them, and you can connect to those different systems. You just basically double click. It'll ask you for the security token. Normally the security token of the render systems, the other systems are 1, 2, 3, 4, 5. So it's really not that complicated. And now when you do that, instead of saying render, you will say team render, and you will say here, you go into your settings, and you will turn on the ability to team render. And so you'll have your team render settings in here, and then in here, you can say team render to picture viewer. So render to picture viewer is Shift R. Team render Shift viewer is Command Shift R, and you can team render. Sounds crazy, but it's fun. It's great. If you have a lot of stuff rendering, let's see how long this took. So this rendered here. This took 2 minutes and 16 seconds to render. So now we have this. We'll just make this a little bit smaller here. We'll zoom in here. We'll get our ship here. We'll look at this. So this is in here. This is what it looked like in there. I mean, you can see it. You can see a glaring difference. So first off, I can automatically see at the low version here, we start to see this gets a little bit softer. Barely, but just a little bit softer on this edge. So if you look really closely at these two right here, you'll see in the inside of here, if I go back to this one, it looks sharp on both of these. This one looks slightly out of focus. And the reason why is because this, we have a shallow depth of field basically in here. But this, I mean, this looks, pixelated right here. This has a little bit of pixelation. This looks a lot smoother. Well, when I zoom in, it doesn't, but you get the idea. This ends up looking a little bit smoother than this. So if you really want a nicer render, nicer control. I mean, this looks dotty and spotty right here. Here it looks really smooth, a smooth edge. Man, I'm going to tell you, it took what, 3 times as long, but ultimately, 3.5. Ultimately, physical render is a little bit more involved. It is a little bit better, and I did it really high threshold, but you'll get a better render out of physical. I think 9 times out of 10, you get a better render out of physical. There's some things you can actually do to beef up how it renders out of physical. You could use physical-based rendering lighting. So there's anytime you see the word PBR, you can render up physical-based render lighting, not Pabst Blue Ribbon, you beer drinker. Anyway, so there's things you can do to bring in physical-based render lighting, which would take advantage of the more physical controls. So it's basically like using a different calculator. Remember when you were in grade school, you used the regular calculator, and then you went and used the scientific, the Texas Instruments scientific calculator? Oh man, Algebra 2, what a good time. Anyway, so those are a different engine, basically a different thing that's doing more complicated math. It can do better math. Now, that said, there's some other renders out there. There's Arnold, there's Corona, there's all these different renders that exist out there. One of the big ones, there's, Octane. One of the big ones right now is something called Redshift. And it used to be Redshift. You could spend a whole bunch of money buying Redshift, and it was really expensive. Redshift allows you to work with the Redshift renderer. And here's the thing, Maxon, the company that owns Cinema 4D, bought the Redshift renderer. Now, here's Redshift. Notice we lost a whole bunch of controls, and that's because Redshift does a lot of things itself. And so it does a lot of work itself inside of here. So in the Redshift controls, there's a whole bunch of things about quality, and it asks you whether you want low, medium, high quality, very high quality, etc. The denoising is a control inside of here. You can learn all about Redshift from someone who's much better at Redshift than I am. You can learn all about the Redshift controls. You'll see even in the preferences, there are some Redshift settings of how it uses Redshift, whether it uses the CPU or whether it uses the GPU. Right now, I'm on an iMac, so this iMac does not have an NVIDIA GPU. It doesn't have an NVIDIA graphics card like an RTX, 3800 or anything in here. But if you have something, years ago, Redshift used to only work on GPUs, so it used to work on only NVIDIA cards. It was like built on the NVIDIA card, and it only worked on the NVIDIA, CUDA cards. But now it works on the CPU, except it's slow as hell and not worth it. My advice is use Redshift, maybe on the CPU. It's getting faster. It's getting better. It's not great, but use it on the system. Now, here's the thing about Redshift. If you're going to jump to Redshift, and I choose Redshift, there's some advanced controls I have in Redshift and some things I can do about how it, the final rendering will be bucket rendering. You can change the threshold of what it is. There's a whole bunch of controls in Redshift of how it handles motion blur, how it handles global illumination. It automatically enables global illumination, what it does for global illumination, whether it uses brute force or Radiance point cloud, how it handles ambient occlusion volumes. So basically how it enables, so all these things, ambient occlusion, global illumination, it's all built into Redshift. Redshift is its own separate brand new engine. Think of it like if you were going to put some kind of a brand new engine in your car that worked totally differently, you were going to have a Ferrari and then you're going to put a diesel engine in it, which would not make sense. But, you understand, I'm making a point here. Anyway, you have this whole separate engine. Once you go here and you switch to Redshift, you're going to see a whole bunch of your controls will change. Your different lights will change now to, say, a redshift spotlight, which is a totally different type of light. So redshift has its own stuff. If you go to materials and you make a new material, it'll make a redshift material. And that redshift material is based on Redshift, which is a node-based material system. Again, a whole different lesson that I should probably learn better inside of here and there. If you make other things and you do things and you make objects and you make materials, basically anything that affects how the quality image looks, you want to use Redshift stuff. There's even a Redshift menu. You can make, instead of using a physical sky or using a sky material, you can actually use an object. So you have objects here like Redshift environments, Redshift dome lights, which would basically be like a HDR, Redshift cameras. You want to use the Redshift camera because it's going to give you better results with the Redshift stuff. So it's basically designed as a whole separate thing. We could rebuild this as a total Redshift workflow. It would take a little bit of time, but I don't want to waste that time. But that's another way you can render this. If I try to render this now, the way that it is with Redshift, it probably won't do anything for me because, well, it maybe show something, but it probably won't look good. Let's try. We'll render this frame out here. It's going to say, well, let's say cancel again. I did the same mistake twice, and you guys didn't say a darn thing. Shame on you. Output, let's say, save this as render Redshift. And we'll save this here and we'll render this as Redshift and we'll hit Shift R and then we'll render this out. Now, this will probably not work at all. Yeah, it's totally not giving me anything good here. Maybe it'll look okay, but it's not going to show me what, because I'm not really taking advantage of the Redshift stuff. I'm not really engaging and embracing the Redshift quality of stuff. It's working pretty well on the CPU, actually, but that's because I'm not really taking advantage of the Redshift lights and the Redshift cameras and the Redshift materials and the Redshift objects and those kind of things. It really wants its own set of render controls. We can look really quickly and see. Interesting. Looks kind of cool. Does some different things here. Takes over some things. It's going to take some longer time to render. Definitely going to take some different degrees of rendering. Should we let this go? All right, as one last thing, I do want to talk about the idea of multi-pass rendering. We're going to do this with standard rendering because I don't want to take too much longer of time. I'm going to stop this render. So we're going to leave this alone. That actually looks pretty good. Different style, different look. Not bad, though. Pretty cool. We're going to stop this render, and we're going to say, yeah, let's stop it. Let's stop for sure. I always get concerned when I stop a render mid-render. I feel like the computer gets mad at me sometimes when I do this. So we're going to talk about multipass, and multipass works this way. We can render out multiple parts of this. So let's go into the render settings really quick. Let's choose standard. We're going to standard. We're going to offer the multipass options. So the multipass says, do we want to render separate things as a separate idea? So let me show you how this works. We could say we want to render this out as a number of different things. So we're going to go here to save, and we're going to render to a different place. We're going to say new folder. I know, new folder. We're going to go to multi-render, multipass. We're going to make a multipass there, and we're going to say ship beauty, or ship, I don't know, space. Let's just call it spaceship. Let's just call it spaceship. It's just a spaceship. Okay, cool. So here, we want to render this out. We're going to want to enable multipass. But under the multipass, we want to render a number of different layers. And I want to show you what this does. Basically, what we can do is we can say, let's render out a shadow layer. And so the shadow layer looks like this. And we're going to render out a reflection layer. And so the reflection looks like that. And we're going to, here in multipass, we're going to say, we're going to render out the global nation. And we're going to render that out as a separate pass. And the ambient occlusion, we're going to render that as a separate pass. And maybe, I don't know, whatever else you want to render here, there's a whole bunch of controls you can render out. We can even render out object buffers. So let's try this. It's going to be fun. We're going to take this right engine, and we're going to go here, and we're going to say right-click, render tag, compositing tag. And we're going to, under the compositing tag, there's something called an object buffer. And we're going to enable object buffer 1 on this. In the left engine, we'll just command drag this down. We'll make a separate one. And we're going to enable this one as 2. So we're going to have 1 and 2. So, okay, we're going to go here, back in the render settings, and we are going to render out an object buffer. Object buffer group ID 1. And we're going to do this again. Render out another object buffer, and we're going to render out group ID number 2. So we have 2 object buffers, 2 and 1. So let me show you how this looks. Okay, this will get complicated. So we're going to render this out with all these passes. Let's just render out one frame. I don't feel like rendering out too much. Yeah, current frame. Cool. We're going to render this at standard, and we're going to say deep breath. Okay, it asks us a question. Do we want to render this out here? Do we want to render this out as a TIFF file? We're not going to do multipass image. Okay, so the multipass images, we don't want to render this out as a PSD. Let's render this out as a TIFF file. And we do want to do a multi-layered file. You can do a multi-layered file, but I'm not a fan of multi-layered files just because for demonstration, I like to keep it separate. This is going to be my multipass render. We're going to render this here to the same place, to the same multipass. Yeah, cool. And we're going to call this spaceship. Okay, we're going to call this spaceship as well. Call spaceship 1. Cool. And so now this is spaceship and spaceship 1. User defined layer names. Nah, that's fine. We will want to create the alpha. Cool. Awesome. Can we render out the alpha as well? We might want to render the alpha. Cool. Yeah, this will render the alpha anyway. All right, cool. Excellent. Deep breath, everybody. We're gonna close this. We're gonna hit Shift R. See if this works. Okay, what it's doing is it's rendering this out. But if you look at the layers, it's rendering out all these different layers here and all these different passes. Let's let this run. We're going here and we're going to say, let's render this out with all these different passes in here. Deep breath, everybody. Wait for it. Zoom in. So it's rendering this out. And here in the layers, it's going to render out a couple things. It's going to render out the alpha, which looks like this. The shadows, which look like this. These are all the shadows that are existing inside of here. It's going to render out the global nation that looks like this. It's going to render the ambient occlusion, which looks like this. It's going to render out the reflection that looks like this. This is the amount of reflection on this layer. What does that mean? Okay, I'll show you what that means and how that works and how that reflects. And it also renders out the object buffers and the other object buffer. So let's talk about this as an idea. This gets crazy. This gets weird and crazy. Okay, I just said weird and weird twice, and then I said crazy, which I already said before. All right, let's take a look at this. Inside of here, we're going to go back into, let's go here to desktop, and we're going to bring in this multipass. And so in the multipass, you'll see that you have spaceship AO, spaceship GI, spaceship object buffer reflection, shadow, and TIFF. So let's take a look at this. Okay. So we have the spaceship here. This is frame 91. Then we have all these different controls of all these different multipasses that we rendered out. So let's take a look. Let's bring all these into After Effects. And we're going to bring all these into After Effects. And so this is the thing we can do. We're going to park on frame 91 here. So we're going to park on frame 91. We're going to go right here, and we're going to drag all these basically here. Okay, so now we're looking at these as different layers. So what do we have here? Okay, we have the ambient occlusion. Well, the ambient occlusion shows the places where there are shadows. So we're going to set this in a blending mode to say multiply, which shows this just as here. We're going to turn this off for a second. So now we have the ship plus the ambient occlusions. So here's the ambient occlusions that are in the ship. They basically look like this. This is showing the ambient occlusions. Well, what if you wanted to play with the ambient occlusions? What if you want to make the ambient occlusions more purpley or more blurry or something else? And you wanted to play with these in here, and you want to go to effect and say something like color correction curves, and you wanted to make them look more blue in the low end or something. And you can make them bluer. And now you can see that I have this blue, these ambient occlusions are coming in with this blueness to them. And that is a separate control for the ambient occlusion. So now we have that. We'll leave that alone just to show you. The spaceship global illumination, we could turn that on and say, okay, this is what the global illumination looks like. We can solo this and see, okay, this is how it globally illuminates. I don't think we need that right now, but we could play with that. We could play with how it globally illuminates, or maybe we could add some, some kind of color or trap code shine on that and make it more shiny. Basically, the parts of this that are being illuminated, we'll leave that alone. This is the object buffer. Okay, the object buffer is interesting. We're actually going to take the object buffer and work it this way. The object buffer says, hey, I would like to keep this ship separate. So let's take the ship here. We're going to duplicate this. And now we're going to use this ship with this object buffer. And the object buffer looks like this. So we want to take this and use this with a track mat. We're going to drag this as a track mat to this ship. So it's going to cut out based on this. Now we have this existing as just basically this as a cutout of this, which means now, since this is cut out, we could change qualities of this. Say we want to add some blur to this. This is on top of everything. So I want to show you what this does. If we turn the spaceship off, we just have, let's see, this is using the spaceships. We want to change this to not an alpha matte. We want to change this to a luma matte. And let's take a look. We have this using the spaceship cut out here. Let's turn the eyepiece. So there's the eyepiece of this. And this is this spaceship. Let me just see. This by itself. Sorry, no matte. Oh, am I not? Oh, sorry, this is the wrong spaceship. Sorry. Sorry. This is why this is not working. Sorry. Let's get rid of this spaceship because we don't want this right now. So I'm getting confused here. Sorry, spaceship 91 TIFF. That's the one I wanted. Okay, so this is the spaceship here. There we go. Okay, let's duplicate this. Sorry, folks. It was really exciting for a second, then I messed it up. We're going to take this and use this as a track matte for this, except we're going to change this to a luma matte. So I want to show you what this looks like. Now it's just showing this one piece. It's using this, the luminance values from this to cut this out and cutting this out here and showing this ship inside of here. So now I could take this part of the ship and say effect, maybe blur. Let's use a Gaussian blur and say, yeah, I want to blur just this one a little bit more. And now this on top of the ship, on top of the ship looks like this one's a little bit blurrier, right? We could do something. We could do something horizontal blur or something. Just do a, weird horizontal blur and have this one be a little bit blurrier. We could also do this here. Command. We can have this again. Command D duplicate and say this and use this object buffer. And now we have this one without the ship. We have this one, and we can turn this off. Spaceship 91 is visible here. This object matte looks like this. So now we have this one and this one. Cool. Let's switch this to, now we have just this, switch this to a luma matte. And now under effect, we could say color correction, I don't know, curves, or maybe levels. Choose levels and let's crush this a little more. Whoops, I'm putting on the object buffer. Wrong place. Here, curves, effect, levels. Sorry, levels will crush this like this. Make this one more intense. Maybe this one's more burned or something. So we can separate each of these as separate layers by using these object buffers. We'll put this on top of the ship. We'll bring the other ship here, and now we have this. So this one's blurry. This one's more intense. We could color correct this, do something else with this, etc. We have a reflection channel. The reflection channel looks like this. Hold on, let me bring up the reflection channel. Let's solve the reflection channel. Let's see. Turn the reflection channel on. Solar reflection channel. So this is the amount of reflection that exists in here. So the parts that are reflective. If we want to make the reflections, I don't know, shiny or something, we could change the contrast of these. We'll leave that alone for now. I don't think we need the reflection channel. We'll look at the shadow channel. And the shadow channel looks like this. This is the amount of shadows that are underneath this and how the shadows are working. So if you wanted to blur out the shadows, you could go to effects, go to blur and sharpen, maybe use like a directional or fast box blur. Make the shadows blurrier. And again, you want to set the shadows to multiply because multiply is going to keep the dark spots in there. So now we have the shadows, and we can change the shadows to amount of blurriness of the shadows. So we can blur out the shadows that exist in this scene and how the shadows fall. Anyway, this is what's called multipass. And a lot of times, if you're doing stuff, you want to have different multipasses, particularly for object buffers. You can have certain things exist there that are cut out of the equation because you want to put this in, like you want to put something between these things and have something laid out like there. You can use different object buffers. It's a cool idea. It's a really interesting thing you can do, a way you can work from bringing one thing there. It's more of a Cinema 4D thing, but it is for compositing in other programs, taking advantage of these object buffers. Anyway, there's a whole bunch more we can talk about with rendering. There's a whole bunch more I'm going to remember as soon as I'm done with this tutorial, but we've talked for a really long time, and I think we've done pretty well. So I'm going to stop here and have fun rendering out of Cinema 4D, make some cool stuff.